We're going to talk about Servlet 3.1 API. My name is Rajiv Mordani. I'm one of the spec leads for the JSR, and along with me I have Xingwei Chan, who's the co-spec lead for Servlet 3.1. Before we get started, I just wanted to get a show of hands. How many people are still writing servlets? How many people know about Servlet 3.0 features? Okay, that's good. And Servlet 3.0 features, how many people know and use today? Okay. So we're going to talk about Servlet 3.1, which is the current JSR, which is targeted for Java EE 7. And it's not yet final, so there is still opportunity to make changes. If you have feedback, this would be a good time to join the users alias on the java.net project and start providing feedback, or send comments to Xingwei and me if you don't want to join and participate in the list. But it is in early draft, so feel free to send us comments and feedback, and we'll see what we can incorporate after discussions with the expert group. With that, the standard disclaimer, I'm sure people attending this have seen this slide umpteen times. We'll go through the agenda. So we'll do a quick overview of Servlet 3.1, what features we're targeting and why we're targeting those. And in particular, we'll highlight some of the things that we've been working on so far. And those are basically the non-blocking I/O API, protocol upgrade support. So for protocols like WebSocket, where the initial handshake happens over HTTP, what we're doing in the Servlet API to address that. We've been looking at some minor but important security enhancements, and there are still some more areas that we need to discuss and close with the expert group. And then a bunch of miscellaneous bug fixes, clarifications in the spec, which have been open since a long time, or since Servlet 3.0. And then we'll hopefully leave you all off with enough resources that you can at least go take a look at the spec and kind of know how to get to us with respect to the API and the JSR. So the feature set for Servlet 3.1, essentially we were focusing in Servlet 3.0. What we did was we modernized the Servlet API to use all the new language features that were introduced since Java SE 5. Before Servlet 3.0, the last major revision happened about 10 years ago. And the Servlet 3.0 API came out around 2009, end of 2009, as part of the Java EE 6 platform. And there what we did was we targeted at modernizing using annotations, making use of generics, and basically making the web XML as optional as possible for most of our developers, so they didn't have to use any of the XML descriptors. So with Servlet 3.1, we wanted to make more incremental improvements. As part of Servlet 3.0, we addressed the problem of asynchronous request processing, but we did not change anything in the container with respect to I/O processing or doing any of the I/O request handling. It was still a traditional I/O API. That can sometimes become a bottleneck for containers. So instead of doing only traditional I/O as part of Servlet 3.1 as an incremental upgrade to some of the changes that we did in Servlet 3.0, we decided to focus on some of the scaling issues with respect to I/O. So we're introducing non-blocking I/O in the Servlet API. And basically, we'll walk through that in more details with code snippets and examples, so you can see how you can actually leverage some of the non-blocking features to get better scalability in terms of the I/O for your applications. In addition to that, we also are going to are in the process of adding support for handling upgrade of protocols. So as part of HTTP, we have the ability to upgrade protocols. Today, the only protocol that really leverages the upgrade mechanism is WebSocket, but in the future, you could envision that more protocols would use the upgrade mechanism. And so what we're trying to do is add a generic mechanism, not tied only to WebSocket, but a more generic version, a generic mechanism to upgrade your protocol to support multiple protocols in the future. And like I said earlier, also we're going to focus on some of the security enhancements to make sure that we address any security concerns that are there in the web container and overall Java EE as far as the web application development model goes. With that, I'm going to hand it over to Xingwei, who will walk through some of the details of non-blocking and protocol upgrade. And I think he plans to wrap it up with a demo that will show how you can actually do an upgrade for a particular protocol. So Xingwei?
Okay. Thank you. Thank you for Rajiv for the introduction. And today we will try to take a closer look on the non-blocking I/O protocol upgrade and security enhancement. Now, first of all, let's try to take a look on a traditional I/O example. Now, in a traditional I/O example, what you try to do is you try to get a servlet input stream, and then after you get the input stream, what you do is just have a while loop, and then you try to read all the data. Now, this is good most of the time, but if there is a blocking in the read here, then the server thread will basically hanging there and waiting for the data available. Now, we try to address this problem by introducing non-blocking I/O. And the approach that we try to use is to using the event listener. Now, let's take a closer look how we are going to solve this problem. We are going to introduce a read listener and write listener, and then we will add the corresponding APIs in the server input stream and the output stream. And I will give you the details how this thing work together. And then I will show you some example and how it work. And if you like to experience how it actually works, you can actually download the Glassfish implementation. Then you can try to play around with the NIO API. Now, let's take a closer look on what is the changes in the server input stream and the output stream. Now, for the server input stream, it associates to one listener at most. So that's why you have a set read listener API here. So it means you have at most one. Now, after you associate input stream with a read listener, then they will start to using the non-blocking I/O. If you do not set the read listener here, then you are still using the traditional I/O. And that is the point that you set whether you are using the traditional or the non-blocking one. And similarly, for the servlet output stream, you have a set write listener here. And once you set the write listener, then you're using the non-blocking output. And you can at most set one of them. You cannot have multiple read listener, write listener. Now, besides you associate a read listener to a server input stream and a write listener to a server output stream, we also add some other APIs so that you can actually achieve this non-blocking I/O. And we add two of them in the server input stream, namely is finished and is ready. Now, is finished basically tell you, okay, all the data has been read, and there's nothing more. And is ready is to let you to check, okay, can I actually read it without blocking? This is very important because when you go back to the traditional example, once you call this API, you already block. There's nothing you can do. So we add an API to let you check, okay, are you ready? Before we call this read API. And we will see how actually it works with some example at the end. And similarly, for the server output stream, you have an API called can write. So basically, you check whether you can actually write before you go to call the write API. Otherwise, you will have the blocking. You may have the blocking in this case. Now, yes?
It's ready and the can write, actually, you are checking whether you can do the operation, right?
Yes.
So why you're maybe using the same names? Can write, can read. Why you
Oh, yeah.
is there any reason for this?
No, not really. I mean, we are still going through some of this discussion. Someone else raised this issue as well. So this is still early draft, and we'll probably go reconcile some of these changes. So for people who couldn't hear, the question is why is it is ready and can write? Why is it not? Why is it not can read and can write? So it's early draft. That's good feedback. You're not the first person to say that. In the next revision, we'll probably reconcile some of these changes and make sure that the APIs are aligned. So we were going through discussions in the expert group, went through, this was the first name that we came up with, and I'm sure there'll be more refinements in the API.
Yeah. Okay, thank you for the questions. Now, then we take a closer look on what is inside the read listener and the write listener. For the read listener, we have three API. The first callback is in the call on data available. So you try to register the read listener. Now, if you can actually write, then the container will call back the listener on the on data available method to inform you that, okay, you have actually some data to be read without blocking. Then inside this method, you can do the processing, the data that coming, and then when you up to a point you cannot read, then you stop and exit the method. And if the data available again, then this method will be called again on data available. Now, when all the data has been read, then at the end of this reading of the input, there's an API call on all data read. It gives you an opportunity to do any clean up. For example, you have allocate a byte buffer or byte array, and it's at this time you can actually clean up the data. And finally, we have an on error here. And whenever there's something happen, then you just call this on error method, then you can do appropriate cleanup or logging if necessary. Now, if you compare this read listener, you can see that this is more look like the JDK7, the completion handler. Because the completion handler, they have a method basically say, when you are done, they call you, which corresponding to on all data read. And they also have a method when they fail, they have a corresponding to our on error method. Now for us, we have one more method here. It's called on data available. Now with this new method, additional method here, we have the advantages of doing something like this. In the case of JDK, you have to allocate the byte buffer that you need to read before you try to call the async IO in the JDK. Now, but for this new API here, you try to delay the creation of the byte array or byte buffer in the on data available method. So if the data is actually not coming, I will not allocate the byte buffer. It's only when it comes, I will try to allocate the byte buffer here. So this is going to be saving the memory consumption in the case of the server environment. Now this is what we have in the read listener. And then for the write listener, it's a little bit simpler. It only have two methods. One is called on write possible. Is whenever you can write the data, this callback will be invoked. And then the next one is on error. Is whenever there's something happen, then they will call back this. And now let's try to take a look on one simple example how this works for the read. Now, this is the same as in the traditional I/O. You get the input stream, and then you get the output stream. And then now you have to set a countdown latch here. I'm going to explain to you why we need to do this in this example. And then you try to create a read listener import, which I'm going to show you an implementation roughly what it is. And then once you create a read listener import, you associate this to the input stream. Then you call a set read listener method. Once you associate to this, it means that, okay, you can start to use the non-blocking I/O when they are ready. Now, then the next step is, now this is important, you have to consume the data as much as possible before they will invoke the read listener. Now, when you try to consume as much data as possible, instead of just doing the traditional I/O that has the input read, that is not enough because the input read by itself can be blocking. Now, in order to make it non-blocking, what you have to do is you have to do this input dot is ready. You have to check, can I read, can I read, can I read? Okay, if I can read, then you actually go to read the data. And then this while loop basically is try to read as much data as possible. Now, once you read as much data as possible, you go out of the while loop, you can do whatever other job you can do. For example, you process the whatever data you try to read. Now, if at that point, while you're processing the data, some more data come in, then they will actually go into the read listener, which I'm going to show you how it looks like in the next slide. But then now, when you go down in here, then there is one command here, you call it wait. Why do we need to wait here? Now, if you do not wait, then you continue go down the method, then you will exceed the service method of the do-get method of the servlet. And then this will end the processing. And then the read listener will not be invoked. So you have to make sure that you are actually still within the do-get method when the listener is invoked here. Now let's try to take a look on the read listener input, how it look like. Now, if you take a look on the read listener input, basically I try to implement the three methods in the interface. One is on data available. You can see that this one is basically the same as the one that you have in the previous slide. You try to read as much data as possible until you cannot read it. And then on the all data read, in here, I will do a countdown here. Now, why do we need to do a countdown here? When you do a countdown here, then you basically signal, okay, basically you are done. You go back to the previous slide, you can see that I try to wait here. If I do the countdown, then this await will automatically return to be true. Then you don't need to wait up to that point. That's how you try to keep the listener within the scope of the do-get method. That is one way to do it. And I'm going to show you another way in example number 3. Now, this so far is for the read. Let's try to take a look on the write. Now, for the write, it's actually quite similar to the read. Okay, you create a write listener input. You try to associate this to an output string instead of an input string. Once you try to associate to an output stream, now then you're doing something similar to the read. In the case of read, the next step is you try to read as much as possible. Now, we are doing the same here. You try to write as much as possible. Instead of calling is ready, now you call the can write. Now, once you call the can write, you try to write as much data as possible. And then at the end, you also have this countdown / await method. The idea is similar to the read example. So,
you can clarify it. You're
yes.
not actually waiting for 8 seconds, right? That's just
At most,
a mechanism required for this to work with the non-blocking, right?
yes, just at most wait 8 seconds. You don't need to be waiting.
That's just an example.
Just an example.
Yeah.
It's not gonna,
No.
customers have to be very happy.
Yeah.
No, that's just an example. That's not a requirement.
Yeah, not a requirement, just an example. Now, since most of us have a concern about this wait example, I'm going to show you another more sophisticated one. Now, in Servlet 3.0, yes?
The write data method, is that the method you will be showing on the slide as well? Because is the output going to be written byte by byte, and how does the write data method know where to produce the previous information?
Okay.
So your question is the write data taking output byte by byte? So your write data is using the output stream, so you're probably going to use one of the Servlet output stream methods, which is either byte or a byte array, or I forget what the other methods
You don't
are.
need to be byte by byte.
It doesn't have to be byte by byte, but you can
don't
pass
need-
in a byte array.
The example suggests that in the that first you can call write data to write part of the output, and then in the listener you continue to write another part of the output.
Yes.
So the write data method needs to know about the different parts of the output and how far it has already progressed. addressed.
Oh, yes, in this case, yes.
And I'm sort of wondering what the right data method would look like.
Okay, I can show you an example on this if we have time. Now, okay, let's go back to example number 1 and number 2. Now, both number 1 and number 2, we have to do a countdown lash, and it seems that people have a concern, do we actually need to wait all the time? It turns out it's not. Now, in Servlet 3.0, what is the most exciting feature that you can dream of? Okay, you have annotation, and then what else? There's one thing, very important. Async, good. Now the question is, can we put the async and the non-blocking I/O together? The answer is yes. Now let's try to take a look how we put it together. By the way, all these examples I already checked into the workspace, so you can actually check it out and then you can download and take a look. Now let's try to revisit our read problem with the async. Now again, they're the same. You're getting an input-output stream, and then now I create async contact. Now there's something different, and then again I will create a read listener info, and then I associate this to an input stream. So far, this is the same, except I pass in the async contact in part of the read listener info, and then as before, which is the same, I try to read as much as possible. And then now, the difference is coming to here. Instead of using the countdown lash, I will ask, am I actually finished? If it's finished, then I call async complete. Now, the difference will be in the read listener info here. Now, in the read listener info, the on data available will be the same. You just have the same logic and you try to read as much data as possible. Now the difference is in the on all data read, there's no space here. On all data read, the async, when it is done, you call the async complete. Now in this case, you end the asynchronous processing here. And then you also have an on error method here. Yes? The on all data read?
Yes, this is the last method, so you can internally call this complete by yourself. Why do you need the developer to write this?
So the question is, why do you need the developer to write the async complete, call to the async complete? So async complete is one of the operations. You can actually, after you're done reading in an async thread, you can actually dispatch back to the container. So you don't necessarily need to call complete. You could dispatch back to the container and do more processing. So if you know the async servlet API, async complete is just one of the methods. The async context of dispatch is another method where you can actually, after you're done reading in your async thread or wherever you're doing your reading, you can then dispatch to back to the container to say, okay, I'm done with my async operation, and you could potentially put the byte buffer or whatever in one of the request parameters and pass that in to the container, back to the container to the servlet or filter, and then continue the processing in the servlet again. So complete is just one of the methods that async context has, and for simplicity, we just put the complete method here.
In the previous example, we saw that you are using wait because there's a problem. The problem is that the flow, the method will complete while this callback was not invoked.
Right. So in the traditional, so is my mic? Can people hear me at the back of the room? Is this mic? So in the traditional servlet model, where we did not have async support, we would at the end of the service method, whether it's a do, get, do, post, when you exit the method, essentially all the objects can be recycled. So to prevent that object from being recycled, if you don't use async context, then the example we used was the wait. If you in Servlet 3.0 with the async support, even if you exit the service method, which is what would happen in this example, the servlet request and response objects are still available for you to continue your asynchronous processing. Those objects are not recycled. And once you're done with you're already out of your service method, so it's not going to be done. Nothing is going to be done in the service method at that point. And from your read listener, one of the things you can do is, okay, I'm done reading. I'm even done producing all my output from here, if the application knew, and then you can call complete. But let's say I'm done reading, but I want some JSP to produce the output. Then I can do async context.dispatch to foo.jsp.
If you encapsulate this async context inside the string,
Uh-huh.
then you can do whatever you want after the one complete. No?
So who can do? Is it the container? Are you saying the container can take that on, or?
The stream itself. will just-
Well, but the stream, the servlet output stream, the servlet input stream or servlet output stream doesn't know what the application wants to do once the async.
Later on, we'll do it later on after the operation will complete.
You might have additional async processing.
You may yeah, exactly. The application has an additional async processing. In the async processing, you're waiting for a web service response to come back from eBay, for example, to get all the current auctions, and then you want to display it to your user via a JSP page, for example. You'll get the results from the web service. Now you'll dispatch to a JSP page to produce the output for you. That's not really in the control of the servlet output stream. That's in the control of the application, what the application wants to do. Okay, maybe I'm not following what you want. We can talk offline after this and see what exactly we're trying to.
It seems to be a good architectural decision because it decouples the specificity of application architecture from the architecture of the server API.
Which one seems
What you've done.
Okay.
Okay.
Yeah, so we can talk offline to see which, what makes it, if there's any way we can make it more simpler or make changes.
Okay. Thank you for the question. And now this is about the non-blocking I/O. Then we will try to go into the second topic, protocol upgrade. And after that, we'll go back to some explicit example, and I will try to go to more co-walkthrough in this case. In that case, now let's try to take a look on the protocol upgrade. Now, protocol upgrade is not something new. It's actually something specified in HTTP 1.1. It's in RFC 2616, and this is connection-based. What does this mean? Now, for a given connection, you can have multiple requests. You can request number one using the connection. Request number two is using the same connection. Now, what it means by connection-based in this case is if you are given a connection and then you use a request number one, and then request number one say, okay, I want to upgrade, so I send an upgrade header to the server, and the server decides to do the upgrade. Once you upgrade, then all other requests is actually using the new protocol. It's not using the original one. So once you switch to a different world. You cannot come back. Now, and then this, once you switch to a different protocol, this new protocol can be something actually is totally different. For example, it can be a check protocol, IRC check protocol, or it can be something which is very popular right now is the WebSocket. So we will try to take a closer look on how this upgrade can actually work in the servlet. Now, let's say a few words about the WebSocket. The WebSocket is standardized by the IETF, and they already have the API in the W3C. And the WebSocket by itself is bidirectional and through duplexed. Now, what it means is like this. Now, you can send a request to the server, and the server can send a request back. And so you can round trip back and forth like this in a given request. So that is the good thing about the WebSocket. And it's also full duplexed, so you can actually send like this at the same time. Now, let's try to take a look on a simple example how the header is actually working in the case of WebSocket. Now, in the case of WebSocket, now you can see the client can actually send a normal HTTP header at the beginning of the handshake. So you can say get, and then a normal HTTP header, you have a host, and then you specify something called upgrade WebSocket and a connection upgrade. Now, and then you have other bunch of the WebSocket header. Now, this is a normal HTTP request during the beginning of the handshake. Now, once you send this one to the server side, now the server can make their own decision to see whether they decide to upgrade or not. For example, you can say, if this is in the weekend, I decide not to do the upgrade, then you don't need to send back a header like this. You can just say, for example, you send an error file or whatever you like. But if the server say, okay, this is the right time you can upgrade, then the server need to respond to the client and tell them, okay, you can upgrade now. And the header that they need to send is in the HTTP 1.1, 101 switching protocol. And then you have specified the upgrade and the connection and etc. Now, so far this is about the handshake. And we will try to take a closer look what we can do for the servlet. Now, basically, what we try to do in the servlet is something like this. Now, when you have a request come in, the request will come into the servlet, and the servlet will make their own decision to see whether they decide to upgrade or not. If they decide to upgrade, then they should call certain upgrade API. And when it is done, then eventually they will delegate all the new work to another class called protocol handler. And that is what we try to achieve in Servlet 3.1. And now we are trying to take a closer look on exactly what this upgrade API is and what this protocol handler look like. And again, we introduce some new classes, and we also add some API to existing classes. And we will try to take a look on this. Now, for the HTTP servlet request, we only add one new API. It's called upgrade. So when you call upgrade, you will pass in a protocol handler. The protocol handler will basically try to handle all the protocol that you need to do, need to process. And I will say more about this later. Now, besides the upgrade, we also add two interfaces. The first interface is protocol handler. And the protocol handler only have one method called init. And the init is you pass in a web connection. And in this moment, the web connection only has two methods. One is to get the servlet input stream. The other one is to get the servlet output stream. And we will go to show you an example on how this works in the case of Echo protocol that I will try to describe. Now, before we go to the code, let's try to take a look on the skeleton of the upgrade example. Now, we will have an upgrade servlet, and then inside the do-get, you will try to read the header and whatever, and then up to a certain point, you will say, I want to check, do I decide to upgrade? If I decide to upgrade, then I will going to call this request.upgrade method. And then we pass in a new protocol handler. Now, all the magic is in here. How does it look like? It turns out this one is actually related to the non-blocking I/O that we introduced at the beginning of the presentation. Now, the protocol handler basically is only have one method in this moment. It's an init. From the init, you can get the input stream, output stream, and then you can create a read listener, and then you can see, oh, you associate the listener with the input stream. And that is what we try to do in this init method. Now, why do we need to introduce non-blocking I/O here? Now, basically, it's like this. Now, once you call the upgrade method in here, maybe I'll go back to this one. Yes. Once you call an upgrade method here, you do not actually process the protocol immediately here, because in here basically is a marker. You mark the connection, say that I want to upgrade. you have to let the do surface method, surface method of the servlet finish. Once it finish, then you also need to unwind all the filter here. You unwind all the filter, and then at the end, you are going to invoke the protocol handler. Now, in this case, that is one of the reasons why we are trying to use a read listener method, because in that case, the data may actually come after the surface method of the servlet, and then they will call you back when the data is available. And now, let's try to do the simple demo. Now, so far, I only give you a skeleton about how the test case look like. Now, let's try to take a look on a real example that I have checked into the workspace. You can check it out. Now, you have in the service method, basically, you say, okay, do you have an upgrade header called echo? If no, okay, then I just return, okay, no upgrade. Then there's no upgrade can be done here. Now, if this is really an upgrade protocol, this is a protocol that I invent for this example, then what I do is, okay, I'm going to set the status, I'm going to set the header that I need to set, and then I will create a new protocol, echo protocol handler. Now, let's try to take a closer look on this one. Now, in the echo protocol handler, you have an init method. And the init method, as I say, is you try to get the input stream and the output stream, and then you create a read listener info, and then you try to associate this read listener info to the input stream. And then the next step is you have to consume all the data as much as possible. That is one thing that I have mentioned in the previous example. I think it's in example number 1 and example number 3. Now, in this particular case, when I consume the data, I will try to write the data at the same time. In here, we can actually also do the non-blocking output, but for simplicity, I will only do the non-blocking input here because I want to illustrate exactly how the upgrade works. Now, so this part, if you remember what I wrote in the example number 1, you can see that this part is actually similar to example number 1. Now, then let's take a look on the read listener info here. Now, in the read listener info, you can see, okay, I will construct a byte buffer, and then I try to consume the data, and then I try to append the byte buffer, and then I try to output it in certain format. Now, again, this is the thing that you have to do. You have to check whether the data is ready. If it's ready, then you read it. If it's not ready, you should not read it. And then you also have the on all data read method. In this case, there's nothing I need to clean up. I just put another marker at the end of the output stream. And then on error, in this case, just print a stat trace. And I'm also going to show you how the client code look like. Now, the client code basically is I try to construct a post request and with all the associated header that I'm supposed to have. And then I'm doing a trick here. I write a hello. And then I do not write the word. Instead of writing the word, I say, I want to sleep for 3 seconds. And then once I sleep for 3 seconds, this will be actually what? It's a blocking operation. Then I make sure that they will call the read listener in order to demonstrate what I try to do. And then you have a write the word again after 3 seconds. And then at the end, this write chunk now is basically I need to write n for the trunking. And once I do this, then I just have a test to pass the corresponding header and make sure that I get the corresponding result. Now, let's try to take a look on how this look like. So I'm going to run this example with a N script. And you can see I will basically do a can you read it, or I need to make it bigger? Okay, basically I just have a target called build, deploy, and run, and undeploy. And then now let me try to do this here. And all. And then at the same time, I'm going to look at the log file. Now, I'm building it, and then I try to run it. And then you can see, if you look at the log here, I have upgrade to use a echo handler, and this I put it in the servlet code. And then now, when I go to the init method, I print this init. Now, and then the next step is we have a loop to say we try to consume the data as much as possible. Now you can see I actually read the hello here. Okay, when they call the on data available, because in this case you hello and then you sleep for 3 seconds, then you go to call back the read listener, and then you call the on data available method, and then I get the world. And then once all data are read, I go to the on all data read. Okay, let's go back to take a look on this. Yes, it's in here. Now you see, if when on all data available, I will put in a system.out to indicate I have actually calling here. You see here. And then when all the data are read, I'm actually calling this. So this is a simple example of how this the upgrade and the non-blocking read is working together in the Servlet 3.1. Yes?
Inside the listener, do you have access to the HTTP session?
Okay, I think it's okay. Now in this particular case, we pass in the HTTP request in the constructor. You can keep the section if you want. Okay, now let's try to go back to our presentation, and then we'll introduce another exciting part, security. Now, security is always an important topic in all the enterprise application. And we will try to, going too fast. Okay, we are trying to do some enhancement about the security. The first one, the enhancement we are trying to do is for the run as. Now, run as is an existing feature in the Servlet specification. I think it exists a long time ago. And now at that time, basically it's like this. Whenever you have a server request, you have a get or post, and then you come into the request. If you put the annotation, you put the deployment descriptor, you can actually say, I want to run this operation as the other role. Once you have this, you can, for example, you grant your role to run an EJB operation. Now, but it seems that it was silent about what happened to the init and the destroy. Now, when you are doing the init and destroy, do we need to also have the run as also work for this init destroy? It turns out it is worthy to do it. Now, for example, you imagine you have a situation, you have a servlet, and you are doing some administration operation. The init may actually create a certain administration and bin. And in this case, you need to have certain privileges to do that. And then at the end, when you shut down the servlet, you call it destroy. Maybe you want to clean up some other ambience. So in this case, it is important for the init and the destroy to also have the run as role. And we have a clarification on the spec and say that the run as will also apply to the init and destroy. Now, this is the first clarification we do for the security. And the second one is we try to do some functionality so that we can do the section, we can handle the section fixation attack problem. Now, how many of you know about the section fixation problems? Okay, good. Now, this is a famous problem. Now, let me try to show you how the hacker is supposed to work, but you better not to do it. But this is how the people, some people did it. Now, one day, you may suddenly get an email or you get a web page from a hacker. And the hacker will actually dress up a nice HTML, and in one of the buttons, the HTML is actually pointing to a certain bank, and then they have a certain hidden parameter about the section ID, or they can have a form, they try to post a hidden field. So it means that the button is actually corresponding to a URL and some section data. Now, they send you the email, and then you take a look and then say, they may say, there's some promotion in certain bank, and then you say, let me click on the button, and then I look at the URL. Yeah, it's right. It's the bank that I have an account there. And this is the real one. It's not a fake one. Okay, I'm going to log in to see whether there's a promotion there. And then I say, I log in, I don't see it. But okay, then maybe I go out to take a cup of coffee. Now, then there's a problem. Because the hacker also have this URL. So it means that he can actually holding your section. In this case, he know, he will keep checking, are you logged in, are you logged in, are you logged in? Because he just need to keep access the same URL, then he can actually get the same section that you have. Once he get hold of your section, he can be, on the behalf of you, do whatever he wants. This is called section fixation attack. Now, how do we solve this problem? Now, the section fixation attack before the Servlet 3.1, I think there are some vendor, they try to solve this problem by changing the section ID on authentication. Now, what does this mean? What it means is something like this. Now, even you give me a URL like this, it's fine. Okay, I take it. You go to a web page and then you type username, password. But once I log in, the server will change the corresponding section ID. Now, in this case, then the problem is solved because the hacker is still holding the old section ID. They do not know what is the new section ID. In this case, they cannot hijack your section. Now, the question is, now, different vendor is trying to solve this problem using proprietary API because you are inside the container, you can actually get whatever object you want and you can modify whatever attribute you like. Now, the question is like this. If you're using 196 auth module, then in this case, what can you do? For example, I'm another vendor. I try to write another authentication module, and I'm supposed to have this feature too, because this is an important security feature. What can they do? In fact, it turns out that if they want to establish this change section ID feature, what they have to do is basically grab the existing section, and then they dump all the data to another hash map, and then they expire the section, and then they create a new one, and then they populate it back. And this is what the people try to do. Now, it seems that this is too much work, and it will create a lot of side effect. Because imagine if the people have registered a section attribute listener, then they will suddenly get a lot of event because you try to populate the event, the object back. So we decide to, we should have an API to help the people to write the auth module. And then we will introduce two API. One is the change section ID API. Sorry. And the other one is we introduce another HTTP section ID listener. And this is important because in the HA environment, you may like to know the section ID is actually changed. Then you may need to actually go to update your HA database or repository. And this is already checked into the Glassfish. You can actually try to play around with it. Now, this is so far, this is for the security enhancement. And then we have two other issues that we are discussing, but we haven't finalized. Another one is about this, is if you have a security constraint like this, and then you only specify for GET, then what happened to other HTTP method? You don't know, right? Now, then it will be by default the server will handle. By default, most server will say, okay, you grant all permission, you can do whatever you want. Now, the question is, how many HTTP methods are there? How many? 6? Is it the only answer? Okay, it turns out, I think it's before Servlet 2.5, it is 6. In Servlet 2.5, I think they add in more, they want to support the WebDAL. In that case, they actually extend the HTTP method to be an unbounded set of tokens. You can take a look on the schema. You can see it can be actually full, bar, and any other characters. So it means that you actually forget a lot of things in setting up the security constraint. Then there was a discussion in the expert group and saying that should we need to do something about the default behavior? So we are still under the discussion about this. If you're interested, you can join the user alias and give us feedback. And the second issue that we are under the TBD is we try to post a request, and then inside the URL you have another parameter, and then you also post the data. Then the question is, what is A in this case? If you call the get parameter A, what will you get? Yeah, you get all of them. In which one is coming first? Hello. Now, and this is going to be sometimes the people concerned. This is actually creating some security problem because again, they can give you a URL that is in the form they like, and then they give you a form, then you post it on that, then you will get some other security issue. For example, if A is actually transferred to account number, then they can give you a URL that is actually pointing to another account number which you may not aware of, but then you may think that I'm actually posting the account number inside the body, but in fact you're using this one. Okay, since I only have about 7 minutes left, I need to show you more about this Servlet 3.1, so I'm going to go a little bit faster. Okay, there's another question about what happens if you tell me A is actually this set. Can you tell something about what is inside the post data? The answer is yes and no. There are many possibilities. So I'm going to let you to figure it out. But it's not one answer. There are many answers here. Now, let's try to go to the miscellaneous section. Now, in the Servlet, even before the Servlet 3.0 API, I believe, they have about the reset and the set character encoding. The reset basically clear the buffer and the header status code, and the set character encoding basically set the character encoding for the writer. Now, let me give you a quiz. Can you tell me what happened for this particular example? Now, you try to set the content type, set the character encoding to be ISO AA591, and then you get the writer, and then you do something, and then up to a certain point, I say, okay, I decide I do something wrong. I'm going to reset the buffer, call the reset API, and then I repeat the set content type, set encoding, and then I get output stream, and then I try to print the data. And of course, I by intention set it to a different content type and a different encoding. Now, what happened?
I think it keeps the same one
You keep the same, which one is the same?
from the top.
You mean the content type? And the character and encoding?
Yeah, I think so.
You think so? Yeah. Okay. Okay, it turns out this is a very tricky problem. The content type will actually change because you clear the header. But the character encoding, you're right. In the Servlet 3.0, you look at the spec, they say that once you get the writer, the set character encoding will have no effect after that. And the worst part is, you get the output stream, what will happen? You already get the writer. Can you get the output stream? No. Then what happened? Exception. So it turns out this line has no effect, and this line it will bomb. So we would like to fix this in Servlet 3.1 because in this example show that once you call the reset, actually you cannot change the character encoding. And the first two bullets basically summarize what I just say is that you can either have one of this and the set character encoding has no effect. And the clarification in 3.1 is basically reset, not only clear the HTTP header, status code, and the data in the buffer, they also reset the state of calling the get servlet output stream and the get writer. So they don't remember whether you have called the get writer or get servlet input stream. We will erase the data and let you call this two again. Now, so far this is about the set character encoding. If you look at the example that I just mentioned, now it's working. The set character encoding now, good, it's working. And the get output stream, good. It will not throw exception because you will reset the state of whether you're calling the writer output stream. And another example that another feature that we try to clarify is the relative protocol URL. Now, in the send redirect API, you can redirect to a local JSP. You can redirect to a JSP that is from the contact root, and then you can actually redirect to another host. Now, notice that if you try to return to another host, in the Servlet 3.0 API, you must specify the scheme here. So you must specify whether it is HTTP or HTTPS. Now, in the 3.1, we add another extension is you can specify a relative protocol URL, or they have another name called network path reference. In this case, you don't need to specify the scheme. What does this mean? It means that they will use the scheme of the corresponding request. If you're coming from HTTP, this is HTTP. If you're coming from HTTPS, this is HTTPS. So again, this feature is already checked in the Glassfish. You can try to download and use it. And then there are some other minor clarification. What happens when the get part and the get pass API, when there is no multi-part configuration, and then we're supposed to throw the exception. And then the other one is about a servlet container initializer. And it seems that there is some confusion. People to think that the metadata complete actually has some effect on the servlet container initializer. And in fact, they're independent. We spell this out explicitly in the specification. And we also clarify that is for each instance of a web application, you will go get a copy of the servlet container initializer instead of a singleton. And this information is in fact in the older spec too, but maybe the wording need to be clarified. So this is not a surprise to other people. And then we also have other clarification, like you add this API, you add the generic, and then you have some other typo and etc. We fix it in the servlet, in the spec. And okay, so far, and if you want to learn more about the spec and the project, then you can actually go to the java.net website, and you can subscribe the user A-list there. You can take a look on also the email archive that we have in the discussion in the user A-list and the expert group. And you can also send email to this webtier@glassfishjava.net, and then you can ask specific question about the Glassfish. And of course, you can download the Glassfish product here, and then you can try it out. Yeah, thank you for the